Hey Year 10s, lovely to see you. Okay guys, so no point in faffing around, done the register already, had a talk through our learning objectives and previous exercise. You guys have had an opportunity to ask some questions. So what we're gonna do is we're gonna go through that, then the next homework, just to reinforce good practice. The more practice I give to you on formulae, the stronger you're gonna be at it. I will be providing you like these kind of formulae questions pretty much all the time now in lessons. I will try and incorporate it into every single one, just to remind you, keep using those complex ions to reinforce that because it needs to be solid knowledge. Yeah, almost reflex in the pace that you need to be able to do it. I love this animation picture of him with a Bunsen burner. Kind of tells us he's a pyromaniac. Yeah, my year 11s commented on that and said, Mr. Duncan, the flame's not big enough. You always like to do things with bigger fire. And I was like, yeah. Okay, so let's share the screen. I'm not going to bother trying to turn off my webcam because it is crashing more often than not these days. So I'm just going to leave it running and cope with it being a little bit sluggish. Okay, so let's crack on, folks. So I set you this as homework. This is actually homework number 4 for you guys, I believe. And again, 50 questions. I'm going to do this with some serious pace today. So my learning objectives are going to be able to create ionic formulae. I know that you guys can do this now, and this is reinforcing this. Yeah, the ability to do this task in chemistry is so vital for your progress. Be able to write word equations, and this is an exam question, being able to read an exam question. I'll write some examples of exam questions, and then your homework will be some real ones, and then be able to translate those word equations into symbol, and then balancing. So, okay, let's see how fast Mr. Duncan can do this. So I'm, of course, not going to bother turning back to the periodic table every time. I'll tell you when I'm pulling it from my memory. Yeah, so let's be super fast. Lithium, oh, I'm going to switch to red. I may as well. Let's see how fast. Well, okay, do you know what? What I'm going to do is for the first 5, I'll show you the breakdown, and then I'm going to pick up the pace even further and do it all in my head. So first thing, lithium is in group 1, so it's +1. Fluorine's in group 7, so it's -1. The charges cancel out. LIF. Zinc is always +2. Nitrate, NO3-. Yeah, you have to know the zinc because zinc is in the transition metal block, but it's always +2. So this doesn't cancel. We're going to do the cross and down. We require 2 minus ions to cancel out the 2+. So we're going to have a zinc brackets NO3 close brackets 2. Tick it if you got it. Next thing, potassium chloride, K+ and Cl-, charges cancel. So KCl. Iron 3 bromide. Now iron, of course, is in the transition metal, but they've given us our Roman numeral. So we're recognizing that it's going to be Fe3+, and bromide is in group 7. So that's going to be FeBr3. Yeah, we need 3 of these ions to balance out the charge. Yeah, we're going to need 3 Br-. Yeah, it's just nice to draw it out at times to show you where the understanding comes from. But so FeBr3, I prefer doing that than doing the cross and down trick. The cross and down trick I'm not a particular fan of. Lithium is in group 1 again. We're going to realize that lithium and sodium make an appearance a lot, so it's worth they'll come to your memory eventually. So then we end up with lithium hydroxide, LiOH. Right now I'm going to pick up the pace. So sodium oxide. Sodium is 1+. Oxygen is O2-. So we're going to have Na2O. Ammonium bromide, complex ion NH4+ and Br-. The charges cancel, NHBr. Iron 2 hydroxide, so we've got Fe2+, it's going to be Fe, open brackets, OH, close brackets 2. Lithium chloride, LiCl. Calcium oxide, calcium is in group 2, 2+. Oxygen, O2-, so it's CaO, it's a cow. Aluminium hydroxide, Al3+, OH1-, cross and down, brackets required. Copper 2 chloride, CuCl2, because the coppers are +2 since the Roman numeral. Barium sulfate is BaSO4. You'll learn that one. It's a solid, a white solid. That's one that you'll have to learn there at GCSE. That is a white precipitate, a white solid, insoluble. Iron 2 carbonate, so that's just going to become FeCO3. That's green if you're interested. Then we've got potassium iodide, Ki. And then we've got ammonium nitrate, so NH4, NO3. That's the first complex formula we've seen. Just to explain that one, NH4 is plus and NO3 is 1-. The charges cancel. It's nice to do that one. 17, so we've got iron 3 fluoride. Then we've got silver oxide. Silver is always +1. That one's something just to quickly mention. Yeah, so we're going to have Ag2O. Then we're going to have magnesium fluoride. Magnesium's in group 2, so 2+. F1-, group 7. Potassium sulfate, K2SO4. SO4 is the 2- ion, K, group 1. Silver fluoride, AgF, soluble, always soluble, never see that one. Magnesium carbonate, MgCO3, because carbonate is CO3 2-, Mg2+ from group 2, charges cancel. Aluminium chloride, AlCl3. And then iron 3 nitrate, so Fe, open brackets, NO3, 3, clever one. Zinc oxide, zinc is always +2, got to learn it, and O2-, charges cancel, ZNO. So out of 25 for the first. I'd like you now to pause the video, guys, and then have a look at all your next answers for these ones here, yeah, and quickly go through your answers, yeah, and then you can make some corrections if you feel like you need to, and then unpause the video and check your answers when you're done. Calcium iodide, this is calcium 2+, and of course I1- in group 7, so CaI2. Sodium nitrate, NaNO3. Lithium sulfate, Li2SO4. Iron 3, that's a nice one, because that one's going to require all kinds of funky numbers. Yeah, that's a really hard, that's a much higher level. So we're going to have two numbers appearing here, crossing down. So we're going to have Fe2 brackets SO4 close brackets 3. That's a challenge one. And then zinc iodide, zinc is always +2, so iodide's a 1-, group 7. Potassium nitrate, KNO3, always nice, needed for making gunpowder. Ammonium sulfide, is going to be, that's going to be a tricky one. Yeah, just to show you how I've done that. We know ammonium is a +1 ion. S, of course, is 2-. We're going to need to do the crossing down trick. It's interesting because the positive ion always goes first. Yeah, so the ammonium goes first in that case. Barium chloride, BaCl2. Copper 2 sulfate, CuSO4, blue. Got to know that. When it's anhydrous, it's white. That's a poignant one for GCSE. When it's anhydrous, so no water. This is when last lesson we had a discussion about hydrated salts as a result of one of my really high challenge questions where Zyna came across a trihydrate. Now, when copper sulfate is anhydrous, that means without water bound in it, it's actually a white solid. This is the test for water, a white solid. When you add water, it becomes what's called hydrated copper 2 sulfate. And the formula is CuSO4.5H2O. It is called a pentahydrate, and that's a blue solid, which is rather nice. It turns blue. Next, iron 3 sulfide. So that's a nice one because we've got Fe3+, and S2- crossing down for both Fe2S3. Aluminium fluoride, Alphi. See, with the 3 Alphi, no, stop, sorry. Copper 2 sulfide, CuS. Iron 2 sulfate, so FeSO4. Just to do that one, iron is therefore a 2+, SO4 2-, so charges cancel. Next one, lithium bromide, LiBr. Sodium fluoride, NaF. Ammonium fluoride, NH4F. Yeah. Iron 2 sulfide, so FeS. Oh, I think we've had that one before. By the way, that one's a lovely example. That one there is fool's gold, otherwise known as pyrite, which is kind of cool, that. Fool's gold. Fool's gold. Quite nice. Then we've got silver iodide, AgI. That one's one for GCSE. That's a yellow solid. A yellow solid. Next one, magnesium oxide, MgO. Potassium hydroxide, we've already seen that one, I think. Cough. Barium sulfide, BaS. Magnesium chloride, MgCl2. Iron 2 bromide, FeBr2. Barium hydroxide, Ba brackets, OH close brackets 2. And silver bromide, AgBr. And by the way, you need to know the color for that one for GCSE as well, which is cream. It's nice to see how the topics link together. So you're going to be picking up chemical tests as part of ionic. Oh, I've just suddenly realized at that stage, I haven't got the YouTube. Eek. Let's go view on YouTube. And then I can split that off and put that over here. There we go. And I can pause the video at that point. There we go. And then pop out the chat, because then I can close that video and save my bandwidth. There we go. At least I can see if you guys comment. There we go. Better. Right, there we go. No comments so far. That's great. So, okay. So it's out of 50, guys. You can now add your score to the score sheet, which would be amazing. Love you to add your score. Look at that. Zyna. Outstanding. 50 out of 50. Superb young lady. Really impressed. Well done. That's great. Okay, so onto I definitely would say we're making progress towards A. Yeah, I will continue to reinforce this every single lesson so that you guys are, ready for your test at the end. So now I need to be able to write word equations and translate to symbol and balance. Okay, so we're going to drop straight into another question. So exam questions on this, exam cues, equations. So what they're going to do is there's generally two different levels of these questions. There is level number 1. So if I just make my pen a little bit bigger. So, and by the way, if I was going to actually level this, I'd probably put the first one is going to be level 3, 4. So version number 1, question 1. So write or create. I like create. They won't say create, they'll say write. Write the word equation. The word equation for the reaction. You're going to see real life questions, guys, by the way, next for your homework. I'll just copy and paste them, but they are as I'm describing. Write the word equation for the reaction between sodium and chlorine to produce sodium chloride. Now you realize that, and I know it seems a little bit ridiculous, this. The reason why that level is so low, level 3 really, is because they've given you everything, and all they're testing you on is being able to put those words into a simple context of an equation, and all they're really testing you on is this. The answer for this question is simply recognizing that arrow. Recognizing that the sodium and chlorine are reactants. This is low level. So these guys, of course, recognition that these are reactants, and they're therefore going to go on the left. Yeah, and they're testing to understand that this is our product, and it's going to go on the right. That's all they're doing in this question. Yeah, because all the words are there. Now they can, sodium plus chlorine goes to sodium chloride. That's all they're doing. Yeah. All they're doing is testing your understanding of an equation that those are reactants and those are products. They can change the level very easily by saying, write the word equation for the formation of sodium chloride. All of a sudden the level changes. So that's the lowest level. Question number 2, write the word equation. I'll try and shortcut my writing. Write word equation. Word equation to produce potassium. Let's do potassium. To produce potassium bromide from its elements. So all of a sudden, the level jumps. So we're now entering into level 4, level 5. Yeah, 4/5. So a step up here, much more challenging. And there's 2 reasons why this is a much greater challenge. One, because they haven't given you the names of the reactants. So the answer for this one, we now realize that we've got our arrow. We understand that this is going to be the product. So there's the level 3 from the previous question. So this is going to be potassium, recognizing that the only bit they've given us is the product, potassium bromide. Yeah. And then we need to split that into its elements. Well, I needed potassium. I don't like the fact that I've run out of space. Potassium plus, and here's the clever bit. Bromide came from bromine. Now that's the big test. Being able to recognize that the elements, the metals, and there's nota benes to be made from this. Yeah, key points, key important things to lock down. Metal names never change. Metal names never change. Yeah, but the non-metals do, and the non-metals but go from their enes or gens, either one. Yeah, sulfur does as well, but they become their ides. I'm going to change my color for that one. Fact number 1, yeah, and number 2, non-metals become ides on their own. Yeah, become ides. And I want to actually give you the example. I'm going to put ... ides. So some examples that are really nice to pick up. Yeah. So if I was to start with nitrogen, yeah, the gen, it'll become, that will actually translate to a nitride. Yeah. So if I did sodium and nitrogen, yeah, I'm going to get sodium nitride. Yeah, it's become an ide. Yeah. If I then did, let's stick with sodium. Quite like the sodium repeat. Let's do this as sulfur. Sodium and sulfur. I'm going to form sodium sulfide. Yeah, it's just reinforcing. I know that we've covered it already. Yeah, there are also the oxides and the phosphides. Yeah, iodides, chlorides, bromides, you know, all of those, but they're becoming ides. But that there, what they're now testing you is, can you take a compound and break it back into the people you made it from? And remembering the change in name for the non-metal. Okay, let's go to the next one. Question number 3, of similar level. Question number 3. So let's do write word equation. Write word equation for reaction between. For reaction between. So ... And we can do multiple ones of these if we like. No, I want to move on as quick as possible. So between, let's do calcium and let's do let's do oxygen. I like oxygen. Yeah. And the question ends at that point. Yeah, there it ends. Now what they're testing you on now is recognizing that they've just given you the reactants. Yeah, they've just given you the reactants. So these are going to be going on to the left. Yeah, and then realizing what's going to happen, you're going to have to build the product. So calcium oxide seems very reasonable. Changing the non-metal name, yeah, from gen to ide. Yeah. Okay, so I think most people are looking at this thinking, okay, do you know what? I'm okay with this. I do want to mention that this evolves and continues to evolve in chemistry. The reason being is you learn that there are lots of types of reactions in chemistry, oxidations, combustions, neutralizations, displacements, and you have to learn to be able to adapt your equation to kind of adapt your process to fit the type of reaction. I'm going to set a challenge question now, just for fun. It's nice for me to now, and you guys should be able to do this because we've already covered reactivity. So this is just a nice stretch question. Is this number 4? I believe it's number 4. Yeah. So number 4, let's do write word equation. Write word equation for reaction of, let's do a displacement. Yeah, let's do a displacement for, let's do iron, and let's do, need something below, and let's do copper. Oof, dropping into symbols by mistake there. Iron and copper sulfate. That's a great one. Right. So now what they're doing is they're getting you to recognize that there's going to be multiple products. So again, levels still between 4 and 5. Yeah, because we're in the word scenario. So I'd like you to pause the video, please, and have a go at doing it. So we've got iron. These are the reactants. Yeah, we've been given the reactants and no products. Yeah. So these are going to go onto the left, plus copper sulfate. And recognizing this is now going to be all about reactivity. Yeah, we know that iron is above copper in the reactivity series. And so we're going to get a displacement. We're going to form iron. Now, I'm going to encourage you to use this number in general because Edexcel like you to focus on the 3+. We're going to get iron 3 sulfate. By the way, if you put iron 2, they'd allow it. Yeah, in this particular context. And copper. They're then going to link this to observations as well. You know, you've got a silver metal going in and a blue solution coming out in a yellow solution and a pink solid. It's nice to mention observations. Well, we love observations in chemistry. Yeah, iron, of course, is a silver solid. Yeah, silver shiny solid. We've got a blue solution of copper sulfate. Yeah, this is a blue solution. We'd never put it in as a solid. That would be silly because it won't react on the surface. Iron 2 sulfate. This is now a yellow solution. You'll learn these. That's aqueous. That's a yellow solution. You'll learn this in chemical testing. Yeah, and this is a pink solid. A pink solid for copper. Nice. Okay, now what we're now going to do, guys, is make the move to translating a word equation to symbol. We're now applying our ability to be able to create formulae. We're going to be using this in the context of equations. Now, students often see these two things as separate items. They think that formulae is one set of questions and equations is another. They're not. They are integrated. Because what's now going to happen is you're going to need to build formulae all the way through. I'll add in a Roman numeral, by the way, for the copper, for those people who like it. So what we're now going to do is we're now going to do the first exercise of translating our equations into word equations into symbol. So what I'm actually going to do is I'm going to go back and I'm going to go through each of my questions in turn. It seems reasonable to do this. Yeah. So what I'm going to do is I'm just going to line that, because what we can now do is we can do kind of like translation. Yeah. This is the word side and this is going to be the symbol version. So what we want to do is we want to take each one of these word equations. And then, this is where my screen's not quite long enough, is it? Each one of these word equations and translate it across. Now, actually, I've suddenly realized going across like that, I don't feel like it's not as good. I don't like it. What I'm going to do is I'm going to do each one, but I'm going to do them below each other because I think there's actually value in that. So, subtitle, translating word to symbol. Okay, I'm actually going to put brackets equations. Yeah. Okay, so our first reaction was sodium with chlorine. So we had the word equation, which was sodium plus chlorine. Now I'm going to underline something here, folks. Yeah, just to remind you, enes. Yeah, I'm hoping everyone's going to go, oh, I know what's coming now. Yeah, if I was in class, I'd be looking to see if anybody can remember why I've underlined that. Yeah, people can put it onto the chat if they know. So just to remind ourselves, put that nota bene again in. This is another very, very, very important nota bene in chemistry. Yeah, any element ending in ene or gen is diatomic. Let's do the example. So change my color. Please do the same. Chlorine. Formulae. Yeah, formula. Cl2. Diatomic. That there is the 2. Remember subscript as well, and not in front but after. Yeah, chlorine. Let's do another one. Let's do hydrogen. Hydrogen. Translate. We see the gen. It's H2 as a formula. Yeah, let's do another one, just for fun. Let's do iodine. Iodine. Underline the ene, recognizing that it's going to be I2. Yeah, there are only, by the way, you can use the table. I love the periodic table. Such a beautiful piece of kit. I absolutely adore this thing. And what you can do is you can actually, very straightforward, to actually identify all of the diatomics. Hydrogen stands out as being special, but then what you realize is there's 7 that you need to know, and it spells out the number 7. Hey, look at that. There are 6 there, of course, and then the 7th is hydrogen. Everyone tends to forget that one. They don't. After a while, this becomes solidified and becomes just part and parcel of your repertoire. I know I'm teaching you a language. I get it. But it's nice that. But as you can see from the table, they're all gens, just to underline that, gen, Ene. People often, Ian will be shouting at me like, astatine also does it as well. It's slightly more complicated for astatine, but yes, it would travel around diatomically if we could get enough of it to prove so. Yeah, it actually has a world record, astatine. It's the rarest element on the planet, 2 grams on the whole planet. So what we now need to do is, taking this understanding and our ability to create formulae, we now need to translate it out. And every single person in this equation has to be translated out. And this is where things get challenging, because students have a habit of forgetting formulae when they're writing equations. So sodium is going to become Na. It's nice to include state symbols as a reminder. So S is solid, sodium's a silver solid. Chlorine, it's an ene, and we know it's a green gas. Love chlorine. Nasty stuff though. Next, sodium chloride. Now I need to translate the formulae. Na will become +1. Cl will become -1. Cross them down, or charges cancel. It forms that, which is a solid. Right, now I have to balance. I now have to, once I've translated, because the habit that students have, the common error, is of course for them to put the 2 there. It's very common, just put the things together. You can't do that, because that's not what's going to happen. Yeah, it's going to form NaCl in a 1-to-1 ratio. Yeah, this formula here tells us that for every 1 sodium, there is 1 chloride. Yeah, for every 1 sodium, for every 1 sodium, I shouldn't do symbols really. For every 1 sodium, 1+ if you like, there is 1 chloride. Yeah, that's what the formula is telling us. Now, so what that means is we now need to balance it. So there's 1 sodium on this side. Yeah, there's an invisible one here and an invisible one here if you wished. Yeah, but an invisible one, and there is 1 sodium over there as well. Yeah, there's an invisible one there. Right, so that's balanced. Chlorine, 2 have gone in, but only 1 has come out. What that now means, I now need to balance my equation, and the only thing I ever do in balancing equations is add the numbers in front. I'm going to add a 2 here. That now multiplies everything here by 2. So I now have 2 chlorines, and I now have 2 chlorines on that side, but now I have 2 sodiums as well. Students, add in numbers whenever you balance. This is a nota bene. Yeah, whenever you balance, the only thing you can do is add big numbers in front. Another very important nota bene. So nota bene. I know I've already given you this before, but it's nice to write it down again and re-solidify. Yeah, so nota bene. When balancing, only add numbers. Only add numbers in front. E.g., yeah, 2Na, yeah, big number in front, not Na2, no, because it doesn't travel around diatomically, yeah, we only add big numbers in front. Okay, now I'm going to teach you a couple of methods for balancing, but I'm focusing today on translating words to symbols. Let's do the next equation. Question number 2 was potassium and bromine. Okay, so question number 2. I'll go back to black. Question number 2. So we have potassium. Here's the word. Potassium plus bromine. Recognizing the ene there, going to potassium bromide. Okay. First of all, potassium is just K. Goes around, it's actually in a giant structure, but in an equation, it's just K. It's a solid, it's a silver solid, it's a metal. We're going to add that to bromine. The ene has appeared. Yeah, so we've got Br2, and actually bromine's a liquid. That's actually important. We've already studied that in group 7. So there's a brown liquid. Oh, bromine, terrifying. It's actually the element that I am most scared of. Yeah, and we're going to form, now I need to build the formula of potassium bromide. K plus from group 1, Br minus from group 7, The answer is going to be KBr, and it's an ionic, so it's going to be a solid. All ionic compounds are solids at room temperature. Right, now we need to balance it. So I have 1 potassium. I have 1 potassium. I'm just going to underline the potassium, actually. I have, change my color. I have 2 bromines, but I only have 1 bromine. Now, what I'm just going to teach you right now is called balance boxes. We'll do some practice of this. I'm just going to write the whole thing down again underneath, because now I've got 2 of them, yeah? And now I've got 2 bromines. Yeah, I'm just going to literally clone it. Yeah, clone. Yeah, and I've now got 2 bromines. So I go, 2 bromines, 2 bromines. This is good. I'm balanced. But now I can say, I've got 2 potassiums now on the right, and I've only got 1 potassium over on the left. So I'm going to add another balance box to him. I'm going to write K underneath it. Another solid potassium. Right, and now all I'm going to do is, now that it's balanced, I've got 2 potassiums. Oh, look, 2 potassiums. 2 bromines, 2 bromines. Yeah, it's actually bromides, but 2 Brs. Right, so now what I can do is just count up the boxes. I've now got my final equation will be 2K, I should do it in red. Final answer, just count the boxes and put a big number in front for the number of boxes. 2Ks plus Br2 goes to 2K Brs. State symbols, nice to include. I always love using state symbols. Yeah, there we go. Okay, are you ready for question number 3? Right, question number 3, calcium and oxygen. Love it. Now this one, again, is going to require you to have a bit of thought about it. You can't rush these equations. By the way, it gets quicker the more you do it. Yeah, people often go, I'm teaching it how to speak chemistry. It's language. So, word equation, calcium plus oxygen. I'm underlining the gen, going to calcium oxide. Right, I'd like you to pause the video and have a go at doing it in that stepwise fashion. Step number 1, take each one of them out into their symbols, remembering what each process is and who they are. Yeah, and then obviously when you get to your formulae of the oxide, yeah, you're then going to consider its formulae. Then once you've done that, have then a go at balancing it. Unpause when you're ready. Okay, so calcium, that's just going to become Ca. Calcium is a metal, they always go in singularly, and it's a solid. Silver, shiny, solid, gotta love calcium metal. It's a beautiful metal, by the way. It's a dark, it's like a gunmetal gray calcium. I don't actually have it in my collection, amazingly. It's because I really need a really good example, but the problem is it's actually very, very reactive. It burnt, great example where you can find it. Calcium is what's found in flares. That reaction right there, calcium plus oxygen, it burns with a beautiful red flame. And I mean, like, it's stunning. Like, it's bright. This is what's in a flare gun. A beautiful, bright red flame. Yeah, just to show you what that looks like. I love my elements. I'd be demonstrating this for you guys in class if we were there. I love burning calcium. It's such a lovely demo. Let's do calcium burning, and you're going to see the flares images. There we go. Oh no, they're not particularly great. I want to burn calcium metal. Calcium metal burning. Do you know what? That's super interesting. No one's bothered to record. That's rubbish. It's what a flare is. The best one there is that one, calcium. That's the best picture there of it. It's so bright, of course, the camera translates it into being white, but it's not. Calcium burning. I'm gonna put flare. There you go. That's what it looks like. Flares. They actually contain solid calcium metal. Yeah, and they just light it. It's by the way, it burns at such a high temperature. It can even burn underwater. How cool is that? It's amazing stuff. So calcium plus oxygen. So it's nice to remember. Diatomic, so plus O2. Right, now we need to do the formulae. Right, I've got calcium 2+ from group 2 and O2- from group 6. Remembering that's an important thing that I always like to refer to back to oxygen because it comes up so often. Yeah, that I like to just remind you. Yeah, she's in group 6, which means she's -2. +1, +2, +3, nothing. -3, -2, -1, nothing. Group 4, kind of +4, -4, but I tend to do nothing because it's covalent, not ionic. But it's -2. Yeah, same as sulfur, same as selenium. So cross and down, they cancel. No, I hate the cross and down trick there. It's horrible. Yeah, they cancel. and it becomes CaO. Now we need to balance. Right, by the way, calcium oxide is a white solid. Yeah, and then we're going to balance it. Well done, Zina. Oh, great job. So proud of you. So what we're going to do is we're going to do balance boxes. I have 1 calcium. I've got 1 calcium. I've got 2 oxygens. I've got 1 oxygen. Clone it. Right, I've got now 2 oxygens. I've got 2 oxygens. That's good. I've got 2 calciums now on the right, but only 1 on the left. Going to balance it there. Right, count up your boxes since I'm now finished. Final answer. 2 Ca solids. Burn in oxygen gas in air, yeah, just 1 of them, to form 2 CaO solids, a white solid. Isn't that nice? These are going to get steadily harder as we move on, I believe. So let's go for number 4. So let's do iron plus copper sulfate. I like it. So question number 4. How are we doing for time-wise? Doing great. Number 4. So we've got the word equation was iron reacting with copper 2 sulfate. Copper 2 sulfate. Going, now this is much more challenging. The level just went up, folks. Iron 3 sulfate and copper metal. By the way, this is actually the extraction, the new method for extracting copper using scrap iron. This is actually a thing. Scrap iron is used here to extract copper because copper is more valuable than iron now. And people throw away rusty cars and all that kind of stuff. So they're using scrap iron to be able to extract copper. So anyway, me waffling. So what we now need to do is translate each one of them out, step by step. Pause the video, folks. Have a go. Translate each one out. Yeah, so step 1, iron metal. It's a metal. It goes in as a solid on its own. Right, I've got to build copper 2 sulfate. This is much harder. Cu2 plus and SO4 2 minus. Right, they cancel out. That is CuSO4 over. Right, now I need to translate this one out. I've got Fe3 plus and SO4 2 minus. Oh, cross them down. Yeah. Common denominator is 6, so I need 2 Fe3 pluses to give me plus 6, and then 3 sulfates to give me 6 minus. That's the concept of charge in that regard. So I'm going to form Fe2 brackets SO4 brackets 3. That's much harder. And copper metal. These copper sulfate, of course, is going to be a solution. The iron 3 sulfate, of course, is going to also be a solution, and the copper is a solid. Right, now I need to balance it. So guys, if you've managed to do that, that is a really, really good step to have made. That's challenging, that, folks. Right, now I need to balance it. So I've got 1 iron going in. I've got 2 ions going out. Add a clone. Add a box. Yeah, by the way, balance boxes. I often, when I sometimes teach this, I tend to say to them, put everything in boxes so you know you can't change what's in the boxes. But in this case, I'm just kind of cloning them. It's easier, saves me having to draw loads of lines everywhere. There we go. So 1 iron, 2 ions, I've added a box. Next, 1 copper, 1 copper. I'm good, that's nice. Right, now this is the tricky bit. What we're now going to do is we're going to treat the sulfate ion as an entire entity. So over here, I have 3 of them, 3 sulfates. I need 3 sulfates on this side then. So I'm going to copy it 3 times. So I copy it 2 more times. There we go. I've now got 3 sulfates, 1, 2, 3, and 3 sulfates on that side as well. Right, now I'm going to check. My coppers. I've got 3 coppers. 1, 2, 3 coppers. Yeah, I'm now going to check on this side. On this side, I've now only got 1. So I'm now going to add 2 more boxes onto that side. And then I'm going to say, right, check everybody. 2 ions, 2 ions. 3 coppers, 3 coppers. 3 sulfates, 3 sulfates. My equation is finished. Count up your boxes. 2 Fe's plus 3 CuSO4s goes to 1 Fe2 brackets SO4 3 plus 3 coppers. And I'm done. So I know it's tough, guys. I really do. Yeah, it takes practice. I'm going to end the lesson there today. I will submit your, I got it right. Well done, Zina, you star. I'm going to go back to this. My camera is still available, which is nice. There we go. Right, guys, I hope you found it useful. I will set your homework on the classroom momentarily. Go and have a nice break time, and I will see you all very soon. It's nice to see all of you year 11, year 10. Take care, guys.